Good morning, everyone. In this presentation, we will see how to install MUSE. For any problem, please refer to the Google Groups as you see the link on the hands-on. The learning objectives for today would be to install the model, run an example, and visualize the results. The first part will relate to the Windows user, so it's about the installation of Windows build tools, and this is not a concern for Mac users because they have this already in their compilers. You can skip this part, both Mac and Linux users. So for everybody else, so Windows users, please follow the instructions as I'm giving you. Now, we need to first start with the installation of Visual Studio. So let's click on the link. Now you will see 2022 as the latest version. We'll scroll down and select 2019 and select download. At this point, you will see several options. I would recommend Visual Studio Community 2019. So you just press download, and then you are basically going to download it here, as you would see. So next thing, going back to the example, we will browse to the place where the executable has been downloaded, and then we just proceed with running it, right? So at this point, you will just need to follow the instruction. You may be required to reboot your system. So obviously I've already set up this section before, and in case you are required to reboot, please do so, and then come back to the hands-on. So next point, we will need to basically download Visual Visual C++ build tools. So now the way we do so is that we browse to the link, we select again 2019, select the download, and then we will be sent on this page. We will land on this page where we have a few things, and especially we are interested in the build tools, which are coming up down here. So again, please, let's select download again, and then we will go to the folder and then basically proceed with the installation. Now let's press continue. Okay, so at this point, let's go back. So we need to select the Windows 10 SDK as an option. So we select build, cancel. So we just need to select essentially what we need. So 10 SDK, and then we press install. The space required would be quite substantial, so you would need a few gigabytes of your hard disk free. Now that the build tools have been installed, we progress with installation of the model, and we recommend the use of an Anaconda distribution for the packages that the software will require. So we just download Anaconda. You will see the downloads appearing at the bottom of the page, and once it finishes, then you can just proceed with the standard installation, which I've already performed in the interest of time. Now, for the progression of the installation, we just open an Anaconda prompt or your terminal, and essentially we recommend to use to create a Python environment. So a MUSE environment where we are basically selecting a certain and specific packages that will ensure reproducibility of your results. Once this is done, we just activate the environment, and then we basically can proceed with the installation finally. So this is the instruction that will allow you to basically install the model, and this will point to the repository of the model. You can see that the model is basically being cloned from the repository, and then all the dependencies will be built. This may take a few minutes. Right. Once this is done, you may have problems with the git command. In case git is not installed in your machine, then you can just install it with this conda install git pip. Further help can be obtained regarding the use of the model with instruction python -muse help, and it will give you a few hints about how how to proceed. So, for example, settings should be a TOML file, and then you can run some setup models. Now, at this point, we just run an example. So you run, for example, we first clone the repository. So we go to the web page, and what we do is that basically is the remote for the model. We can basically either do a git clone or download the zip. So this would be basically on your on your downloads folder, and then depending on where you are, you can just unzip it. You can just browse to the place and unzip it. Yeah. Just extract it. Once this finishes, we can browse to the place where the examples are, which is in SRC Muse data example at default. And then we can just do a Python -m muse path. Oops, sorry. Path to the toml. This will run for a bit, and then we will see an example of results. It's almost finished. It's a 2015 nearly. Once the simulation is finished, we can check the results from obtained from the model. So typically these are in the installation place unless you specified something else. So we will find these results for the here, and you will see the results collected by folder. You have per each sector capacity. These are disaggregated per year. So this basically will represent the capacity per year in additional to the decommissioning profile. That's an example for the capacity for the gas sector. The same would be for power and residential. Among the outputs, we also have converged prices for each commodities of interest and region and year. The values are also reported by time slices, so you will have yearly and weekly time slices with diurnal peaks. Having a better look at the capacities installed, we can open the MCA capacity file, which collects all the capacity for all the sectors, year, and region technologies. So we can use the pivot table to understand and have a look at the results. So what we can see here, for example, we can report the values, and the year would be in rows, technologies would be in columns, and we can filter by sector. Now this is a count, so we don't want that. We want the we want the sum. Right, that's that. So we can select, for example, one sector, power, for example, and we can just display it so we can see what the result would look like. That's, yeah, okay. So thanks again for watching. This concludes the tutorial, and